Hello student, welcome back to the session. In the last session we were talking about the principle of duality in Boolean algebra. In this session let us talk about the Boolean theorems. This is nothing like your theorems which you have studied in geometry. It is very easy. The Boolean theorems are derived using Boolean postulates, and these theorems are used for simplification of Boolean expressions. Okay, these derived from Boolean theorems are derived from Boolean postulates and are used for simplification of Boolean expressions. Okay, now how are you going to prove? It's very easy to prove. We use we prove the theorems by substituting all the possible values. When we are saying all the possible values, we are considering only zeros and ones, that is the binary values for the Boolean variables. This method of proof is known as proof by perfect induction. That is proving of all the theorems using the possible values, that is 0 and 1, is known as your proof by perfect induction. And a truth table, as we had done in the last class, is also known as the one of the proof by perfect induction methods, because we are using only zeros and ones for the input and the output variables. Now let us talk about the list of Boolean theorems. We'll just give the list now, and then later on we'll start proving. So the first one is properties of 0 and 1. This is with AND operation. Okay, what are these properties? 0 into x equals 0, x into 0 equals 0, 1 into x equals x, x into 1 equals x. We are just going to give a list now, and then later we'll show the proof. Okay, this is the one of the theorems. And then you have properties of 0 and 1. This is using OR operation. So this states that 0 plus x is x and x plus 0 is x. In the same way, 1 plus x is 1 and x plus 1 is 1. And then we have idempotence law. This is important because they can ask you to prove any of the 5 Boolean theorems for 5 marks. So each one carries 1 mark. So idempotence law, x plus x is always x and x into x is also always x. And then complement law, x plus x bar is always 1 and x into x bar is 0. These laws are very important while you are solving, as we said, use your Boolean expressions. So you should know these rules. And next, involution law, x double bar is always x. Commutative law, which you have learnt in the earlier classes in the arithmetic and all. Commutative law, x plus y is the same as y plus x, and x into y is the same as y into x. And then we have associative law, which states that x into y into z is the same as x into y into z. Also, x plus y plus z is the same as x plus y plus z. And we have the distributive law that states that x into y plus z is the same as x into y plus x into z, and also x plus y into z is the same as x plus y into x plus z. We have absorption law that states x plus xy is always x and x into x plus y is always x. And which you have already learnt in 10th standard, De Morgan's theorem. We are just showing it in a different variation. X plus y the whole bar equals x bar into y bar. X into y the whole bar equals x bar plus y bar. So these are some of the list of the Boolean theorems, and we will be showing the proof for this now using the proof by perfect induction method. As we said, proof by perfect induction method means using zeros and ones in place of x and y. So the first one, properties of 0 and 1, right? So this is with the AND operation. Now first, what is the statement? 0 into x equals 0, right? 0 into x equals 0, x into 0 equals 0. So this is a logical multiplication and operation. So if x is equal to 0, then this shows that 0 into, in the place of x over here, whatever you have x, you are going to place 0. So what is 0 into 0? This is 0. Then if x equals 1, we have the statement 0 into x equals, that is 0 into x plus x is 1, 0 ones are 0. So it is proved, hence proved. And we have one more statement, 1 into x equals x, right? So if x equals 0, then 1 into x becomes, what does this show? 1 into, in place of x you are substituting 0, so 1 zeros are 0. Then if x equals 1, what happens? We are saying 1 into x, that is 1 into, in the place of x you are substituting the value 1, so 1 ones are 1. So what is the statement? 1 into x equals x, whatever the value of x is. Here x is 0, right? X is 0, the output here is also 0, that is x. If x is 1 over here, then here also the output is 1. Okay, so 1 into x equals x, whatever the value of x you have, it is the output is the same as that. So this is your properties of 0 and 1 using AND operation. Then you have properties of 0 and 1 with your OR operation. So what is the first statement you have? 0 plus x equals x, right? 0 plus x equals x, or x plus 0 equals x. Now the proof, if x equals 0, then 0 plus x becomes 0 plus, in the place of x, what is the value of x? 0. So you put, substitute 0. 0 plus 0 is 0. So is it the same? Yes. Then if x is equal to 1, then what is the value? 0 plus x becomes 0 plus, instead of x you substitute the value 1, that is 0 plus 1 equals 1. So this remains the same, hence proved. 0 plus x is x, whatever the value of x is. And the next statement you have 1 plus x equals 1. So if x is equal to 0, then 1 plus x becomes 1 plus, instead of x you substitute the value 0. So 1 plus 0 equals, what is 1 plus 0? 1, right? So what did we say? 1 plus x is always 1. So this is 1. Next, if x is equal to 1, then 1 plus x becomes 1 plus, instead of x you are substituting the value 1, so 1 plus 1 is always 1, so the output always remains 1, hence proved. This is the proof for your first properties of 0 and 1 using OR operation and using AND operation. Now the next second, let us go for the, which is the next, I think it is the idempotence law. Idempotence law. So what does this idempotence law state? It states that x plus x equals x and x into x equals x, right? So you have to prove this now. So if x is equal to 0, what happens? Let us show in the next line. Okay, if x is equal to 0, x plus x becomes 0 plus 0. You are substituting the value of 0 in this places. So 0 plus 0. 0 plus 0 is 0. Right? X plus x is x. So x is 0. The output is also 0. Then if x is equal to 1, then it becomes x plus x becomes 1 plus 1 is again 1. So x and x remains the same. And you have the other statement, that is x into x equals x. So let us prove this. Now what are you going to take now? The same way you are going to prove all the theorems. Substitute zeros and ones in place of x. If x is equal to 0, so x into x becomes 0 into 0, that is 0. If x is 1, then x into x, that is 1 into 1, that becomes 1. So whatever the value of x you have, if x is 0, this output is also 0. If x is 1, the output here is also 1. Hence proved. So if you are going to show this in a form of a truth table, we have two outputs, x and x, right? So you have x plus x and x into x. If x is equal to 0, x plus x becomes 0, x into x becomes 0. If x is 1, x is 1, 1 plus 1 is 1, 1. So this is what we said, x plus x remains the same as x. This is your truth table. And we went for, this is the second, right? So let us go for the next, that is your complement law. So what does the complement law state? The complement law states that you have two statements, right? So that is x plus x bar is always 1 and x into x bar is always 0. So let us go for the first statement, x plus x bar equals 1. So if x is equal to 0, then what happens? X plus x bar will be, in the place of x you are going to substitute the value 0 because x is 0, plus what will x bar be? As we said earlier in the earlier session, x bar means the complement, that is the opposite. X bar becomes 1, so 0 plus 1 is 1. And then if x equals 1, then x plus x bar will be, in the place of x you are substituting the value 1, x bar becomes the opposite of 1, that is 0. 1 plus 0 is 1. So hence proved, x plus x bar is always 1. And the next statement, x into x bar is always 0. So now we are saying we substitute the value if x equals 0. If x equals 0, what happens? X into x bar, that becomes 0 into x bar. Now as x is 0, x bar becomes 1. 0 into 1 is 0. And then if x is equal to 1, then x into x bar becomes 1 into, instead of x bar you substitute as 0, 1 into 0 is 0. So x into x bar is always 0. Hence proved. And next you have the involution law. Involution law states that x double bar is always x. So what is this? It states that when you complement the variable twice, then we get the status of the original variable. Now for example, this is a proof. If x is equal to 0, now x double bar, what is the value of x? 0. Double bar, so 2 bars. If you have 1 bar, what happens? 0 bar is 1, that is a complement. So now this again it has one more bar, 1 bar is again 0. Okay, so 0 bar is 1, the upper bar you have this 1 bar is 0, so it remains the same. If x equals 1, then x double bar equals 1 double bar. What is 1 bar? 1 bar is 0, and again 0 bar is 1. So this becomes 0 bar, again it is 1. Hence proved. This is your involution law. Let us stop this session here now and continue in the next session. Thank you.